Welcome to tonight's episode of National Geographic, where we'll be talking about little auks. Little auks are these amazing little creatures from the Arctic and one of the most populous seabirds in the world, estimated at 30 million individuals. Previous studies have indicated that little auks play an important role in transporting nutrients from the sea to the land, mainly operating in the North Water Polynya between Canada and Greenland. They feed off the coast, and their guano, or excrement, fertilizes plants, benefiting herbivores, land animals, and their predators. Due to their high population and ability to fertilize, little auks are very important to the Arctic ecosystem, making them a keystone species. Analyzing how these little auks feed will be an important part of knowing how well they will be able to survive global warming. As climate change progresses, certain resources and habitats will become limited, especially in the Arctic. By understanding how different organisms forage, we may be able to discern which organisms are better suited for a changing environment. In terms of little auks, studies have estimated that they need to feed on approximately 60,000 copepods per day to make up their diet. If this is the case, then little auks must eat approximately 6 copepods per second, suggesting that they must be non-visually filter feeders. New research is calling this original assumption into question, especially as Earth's temperature is rising. Birds will face even smaller zooplankton populations. Little auks are expected to respond to climate change by feeding on even smaller prey, thereby increasing the capture rate in order to meet these daily demands. Little auks have never been observed feeding in the wild, so only predictions have been made about their foraging habits. Let's take a look at our lead scientist in the field, National Geographic explorer Dr. Burns.
Hello there. My name, Dr. Burns. I'm a professor at Siena College, a biomechanicist, if you will. Good to see you. Just take a second. I need a sip of my Coca-Cola. You see, we're in the Arctic, and unfortunately the Arctic only seems to carry Pepsi products, so I had to bring my own Coke. Anyway, why are we in the Arctic? Because we, today, are going to find the little auk. Let's see what tools we have to nab the little fellas. Why don't we? We got the binoculars already ready to go. A little snack for later, not these. In case it rains. Ah, yes, this will help on a Scantron, but not right now. Meat thermometer, no. Mask, not quite. My milk frother? Not now. Glasses, no. Okay, a replica of what it should look like. Ah, yes. My trusty lasso. Let's see what we can capture today.
Little hook. Right there. Get it.
Evidently that didn't work, so let's try the noose trap now. Well, you get the point. Now that we've captured some little auks and creatures like this one, let's go take a look at how they might actually feed.
It's important that we know the different types of feeding that we're going to be looking for. There are many types of aquatic feeding, such as lunge feeding, ram feeding, filter feeding, suction feeding, and other crazy things. Ram feeding is when a fish approaches its prey quickly and then engulfs it. On the other hand, lunge feeding is when an animal like a whale speeds up very fast, then opens its mouth to engulf the prey, which is really just a specialized form of ram feeding. Now back to Dr. Burns for a special example of filter feeding.
They've been predicted to be filter feeders. So let's take a little look at what that may look like.
Well, maybe not that type of filtering. Filter feeders typically have specialized structures that allow them to feed. Filter feeding involves animals taking in and processing a medium holding their food, such that the medium is filtered through and food can be retrieved out. Last but not least, there's suction feeding, which is exactly as it sounds. The predator will quickly open its mouth, creating a pressure gradient. It'll approach its prey and suck it in. New research from our team in the field shows that little auks are actually suction feeders, a quality not yet seen in seabirds. Let's take it back to Dr. Burns to see what experiments were run after capturing some of these little auks.
Now that we've captured the little auks, we've been putting them through some testing to see how they actually feed. A pool was set up with salt water, and copepod density was estimated based off of known counts of subsamples. An underwater video setup using a GoPro allowed for observation of little auks without the presence of humans.
While observing the little auk feed, there were surprisingly no observations of filter feeding, but instead the little auks underwent what is called visually guided suction feeding. Well, let's take a look at that again. Looks like that little auk had some trouble. Let's look at a different one. Yes, here we can see it much clearer. Let's slow it down and look at that again in phases. We can break it into 5 phases. First, there's prey detection as seen in A and B, with the prey being a coped encircled in red. Next, there's head strike and beak opening circled in C and D. Then, the little auk undergoes a gular extension, which is when the sublingual pouch extends and prey is taken in as seen in E. Then, the beak starts to close while the pouch is still extended as seen in F and G. And lastly, water is expelled through the nostrils in H and I. Now, let's transition to look at what some of the data collected from these studies looks like.
Oh, hi there. Don't mind me, I'm just finishing up a couple calculations. Alright, let's take a look at this table of our data here. So on the table we have 10 different birds that we observed, and we measure different dive durations, capture intervals, the capture rate, and the number of captures observed for each bird. What we thought were the most important pieces of data were the capture intervals and the capture rate. So we saw that every bird dived for about 0.81 seconds and had a capture rate of about 1.35 copods per second. What this data shows us is that it's a lot lower than the estimated 6 copods per second from a previous study by Harding et al. In 2009. And what this tells us is that the auks probably don't feed using a filter feeding mechanism, but rather use a suction feeding mechanism, which has never been seen in a seabird until today.
Now, let's move over to our critic, Anton Ego, who also has a few words about this study.
Like all good critics, I have a taste for something remarkable. There is a safety and security with the familiar, yet there is also a hunger for the new and novel. In the case of this study, I have tasted something remarkable. Yet, like all things good, there also comes the bad. First, the little auks were only observed foraging for about 2.7 hours underwater per day while in captivity. While no events of filter feeding was observed, this could be different when little auks are in the wild. Additionally, the little auks were only given copods as a food source, so there's the assumption that adult birds eat the same prey as their chicks. However, little auks actually eat other crustaceans and fish as well, which would greatly increase their caloric intake to necessary levels. Nevertheless, at the end of the day, I would like to meet the chef to congratulate them.
What a great critique of the experiments ran by our field scientists. Now, let's summarize. So, surprisingly, there were no observations of filter feeding, and this is the first time suction feeding has been specifically identified in a seabird species. While suction feeding is common amongst fish and marine mammals, this new understanding beckons many new and exciting questions for how seabirds feed. This new understanding can help us make predictions on how resilient the little auks will be against climate change. While less efficient than filter feeding, this visually guided suction feeding is more effective when faced with dwindling zooplankton populations from climate change. In this way, little auks might be more resilient than initially predicted. These little auks will be more adept at surviving, allowing for their continued fertilization of land around Greenland and Canada, keeping foraging options open for the immense biodiversity that relies upon them and their guano.